Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 3 for this week. And sometimes the production time on these takes longer than I anticipate, so I apologize for this getting out so late. But the nice thing about the bonus weather videos is that they're not time sensitive, and so you can pretty much watch them whenever you want. With the daily weather updates, if you wait a day, then it's sort of outdated information. But anyway, let's go on ahead here and talk about fronts. And there are several different types, as you all know. And so the classic cold front is the cold air mass that is advancing in the direction that those triangles are pointing. And since cold air is more dense than warm air, it pretty much goes where it wants to go. So as long as the winds on the cold side of that front are pushing toward the boundary, the cold air is going to advance. Now, with a warm front, sometimes I hear people say, well, the warm front is warm air pushing cold air out of the way. Okay, that can't happen. That goes against the laws of physics and thermodynamics and everything else, is that since cold air is more dense than warm air, it has to retreat, okay? I used to use the example like if I'm in the boxing ring with Muhammad Ali, the only way that I'm going to win that fight is if he quits, okay? He's the cold air, I'm the warm air. And so warm air does not push cold air out of the way. If the cold air retreats, then the warm air can come in to replace it. Now, if the boundary between these two dissimilar air masses is either not moving at all or only moving very slowly, it is classified as stationary. And I always kid about the fact that stationary fronts look good on paper. And then the one type of front that is not talked about a whole lot, or at least not understood maybe, is an occluded front. And here you have alternating triangles and semicircles all basically pointing in the same direction. So what happens here? Well, the classic Norwegian cyclone model is that you have a low pressure area here, a warm front extending out to the east, and a cold front extending down to the south. So you have cold air to the north of the warm front, to the west of the cold front, and warm air in here. So this is classified as the warm sector. All of the temperature differences or gradients, if you will, are always on the cold side of these boundaries. The warm sector is uniformly warm or almost uniformly warm. And then you have a temperature gradient to the north of the warm front and also behind the cold front. Now, the cold front tends to move faster than the warm front. And so it's chasing it, and sometimes it catches up. And so then you get a situation like this where you get a low pressure area with an occluded front extending out to the east, and then the warm front and the cold front in their same basic position. And so what this turns into is a cold front aloft. If you were to go up a few thousand feet, it would still be a cold front, but the cold air basically at the surface, basically, it's the same thing now here as it is here, okay? It's cold up here, it's cold down here, and the warm air has been displaced way out to the east, okay? So in this situation, when the low pressure area becomes separated from the main temperature gradient at the ground, then it begins to weaken, okay? And so when you see an occlusion or an occluded front developing, you know that that storm has peaked, and it is now going to weaken, and the pressure in the middle of it is going to go up. Okay, and there's the labels for cold, cold, and warm. And the cold front catches up with the warm front, and that's why it occludes. Okay, now, the slopes of fronts. This is really interesting. It turns out that the slope of a cold front is steeper than the slope of a warm front. But if you actually look at the dimensions, okay, of this, it's very hard to see, okay? So the slope of a cold front is basically 1 unit up to 100 miles east-west, okay? And so the slope of a warm front is 1 to 200. And if you look real carefully, you can tell that this blue line, and the cold air is right in here, okay? The blue line is a little farther away from the green, which is my poor man's representation of the ground, than it is down here. But man, I mean, that's a very, very small difference. So what you see in a lot of textbooks is that they will exaggerate the vertical scale in order to make their point. And so that's what I'm going to do here. I'm going to basically multiply the vertical scale by 25, and now you can see that there is quite a bit of a difference in terms of the cold front slope and the warm front slope. Okay, and what I did again was multiply the vertical scale by 25. Now, there are two types of cold fronts, believe it or not. Most of them are what is called a Kata front, okay, where you have very strong winds on the cold side of the boundary that are advancing the cold air very quickly. And the cold air is blowing along this slope here, and then when it gets to the leading edge of it, it sinks, okay? So with really, really strong cold advection going on in here, the warm air out ahead of this front is forced to go straight up. Okay, it may be coming toward the front, but when it reaches the front, because of these strong winds in here, then it turns upward. And so all of the sensible weather is right at the leading edge of the cold air. And this is where you'll get showers and thunderstorms and all that type of thing. Now, that's called a Kata front. And that's because Kata means down or sinking, and that's what the air does when it comes to the leading edge of the cold front here. It basically is moving east or moving ahead, and then it sinks very sharply right at the leading edge. Now, in the other situation, what if you have really, really weak winds on the cold side of the boundary and stronger winds on the warm side of the boundary? Well, now the cold front isn't being quite as aggressive, and so the flow from the warm side of the boundary is now able to run up and over the cold dome. And this is actually acting like a warm front. This is the same schematic that you would see with that. And so now, when you have the warm air gently ascending along this boundary, then you get clouds and precipitation way behind the cold front itself. And so you will get, steady rain back in here and cold temperatures. And we call this an Ana front because Ana means up, okay? And so you have rising motion behind the cold front, and as a result, you continue to get clouds and precipitation. Again, most cold fronts are Kata fronts, but every once in a while, you'll see one of these where most of the precipitation is behind it as opposed to ahead of it. And this is the reason why you get those two different scenarios. Okay, there are the credits. That is the bonus weather video for this Friday. Hope you found that mildly interesting. The next daily weather update, of course, will be coming up on Monday, as well as the next bonus weather video as well. So again, have a great weekend, everybody, and we will talk to you soon. See you later.